In section 6.1, we're going to be learning about a new way to measure an angle. It's called radians. So think about radian measure like you do the temperature. So we have Fahrenheit, and we could easily convert that to Celsius. Sometimes it's better to use Celsius. I mean, think about it. If, Celsius, if 100 degrees Celsius is boiling, Fahrenheit 212, that might be a little bit harder for some people to remember. Or if 0 Celsius is freezing, that's a little bit easier than 32 degrees Fahrenheit to remember. So there are some benefits and drawbacks of each. Same thing with angles. We can measure in degrees, and we can also measure an angle in radians. So the question is, what is a radian? I'm going to draw you a circle. And this line right here is the radius, right? So if I were to take that radius and drape it around the outside of the circle, it would maybe get that far. That would be 1 radian. 1 radian is about equal to 57.3 degrees. If I were to wrap another radius around the outside of the circle, it might get to be like this far. That would be how far having 1 radius plus another radius is. So 2 radians would be that angle. And if we double that, that's 114.6 degrees. Now let's do another one. If we were to do it again, we'd almost get all the way around. This would be 3 radians right here. That would be this angle. So it's almost all the way around, but it's not quite. So 3 radians is about 171.9 degrees. But to go all the way around, what's the total angle measurement of a straight line? It's a little bit more than 3, right? We'd have to go this much. That's an extra 0.14 radians, or 3.14 radians, or pi radians. Pi radians is equal to 180 degrees. That's how they convert. Just like 12 inches is equal to a foot, pi radians is equal to 180 degrees. So that's what a radian actually is. It's the degree measurement of 1 radius along the circumference of a circle. So sometimes it's more convenient to measure an angle in degrees or in radians. One thing that's easier to do in radians is arc length, the length of an arc. And we'll be talking about that a little bit later today, or in this section. So we should know how to convert. The conversion from degrees to radians or from radians to degrees. If you want degrees, we multiply by our unit rate of what you want divided by what you don't want. So you'd multiply by 180 degrees if you want degrees, and you want to get rid of radians, that goes on the bottom. If you want radians, you multiply by what you want, pi radians, divided by what you don't want, 180 degrees. The units will cancel out. Just like if we were going to convert like 8 inches to feet. Well, you want feet? Well, I know that 1 foot is the same thing as 12 inches, right? So when you multiply this, the inches cancel out and you get 8 over 12 feet, or 2/3 of a foot. That's how you convert with like feet and inches. Well, you're going to be using the same thing with degrees and radians. So let's practice conversions. Convert from radians to degrees. And if we have radians, we'll go the other way, right? If we have degrees, we'll go the other way. So I have 6 problems. Let's convert 45 degrees to radians. Multiply by what you want over what you don't want. The degree symbols cancel. And I know 45 goes into 180 4 times. So this is just going to be 45 pi over 180, which reduces to pi over 4. What about negative 270 degrees? If we want radians, we're going to multiply by what we want over what we don't want. Degrees cancel. And you could even just ask your calculator to do this conversion for you. And you could cancel out the zeros. And I know 3 goes into 27, or 9 goes into 27 3 times. And 9 goes into 18 twice. So that's something you could easily do in your head. How about a decimal? So what if we had 249.8 degrees and we wanted radians? You multiply by what you want over what you don't want. Now usually our answer in radians is with pi in it. That's called in terms of pi. But if you're converting from a decimal, what we could do is we could just leave the answer as a decimal. So what I'm going to do on my calculator is do 249.8 times pi divided by 180. And that comes out to 4.3598 radians, or just 4.4 radians. Now if you don't write degrees, it's automatically radians. So just make sure if you mean degrees, put a degree symbol. If you mean radians, you could write RAD if you want, but without a degree symbol, it automatically means radians. Let's go the other way. What if we had 9 pi over 4 and we want degrees? Multiply by what you want over what you don't want. So I'm going to do 9 times 180 and divide it by 4. And that's 405 degrees. I'm going to do negative 5 pi over 6. I want degrees, so I'm going to multiply by 180 degrees over pi. Pi's cancel. Negative 5 times 180 divided by 6 is negative 150. And let's do one more. How about 4.25 radians? Well, if you want degrees, you're going to have to multiply by what you want over what you don't want. But you see how this is already a decimal? I'm going to type into my calculator 4.25 times 180 and divide it by pi. And I'm going to get a decimal here. This is 243.5 degrees. So that's how we convert from degrees to radians and from radians to degrees. One thing I just wanted to show you, we're not going to spend a whole lot of time on it right now. We're going to talk about it some more in the next section. But just basics on the unit circle. Just want to show you basically how to work your way around the unit circle. Some of you might have learned more of this when you were in high school, but I'm not a huge fan of the unit circle just because it encourages people to memorize different values. I'd rather you figure them out. But let me show you. First thing I'm going to do is just draw a circle here. When we start, we'll label the quadrantal angles. 0 degrees, 90 degrees, 180 degrees, 270 degrees. Let's convert those to radians. 0 degrees is the same as 0 radians. 90 degrees, let's do it over here. 90 degrees times radians, so we want pi over 180, would convert to be pi over 2. So maybe it's better if I just write this, 90 degrees or pi over 2. 180 degrees, if we do 180 degrees times pi over 2, times pi over 180, it's just going to be pi. So 180 degrees or pi radians. 270 degrees, I'm going to multiply 270 by pi over 180. And we saw this before. This is the same thing as just 3 pi over 2. And that gives us degrees and radians for our quadrantal angles. Now, let's do 45 degrees. So I'm going to draw a line like right here, and right here, and right here. This angle, if you start on the positive x-axis and go up to this line, that's going to be 45 degrees. And 45 degrees is the same thing as pi over 4. Now let me show you why radians could be good. If that's 1 pi over 4 to get 45, this would be 2 pi over 4 because that's really 45 times 2, right? So that's 2 pi over 4, which is pi over 2. This would be 3 pi over 4. This would be 4 pi over 4. This would be 5 pi over 4. This would be 6 pi over 4. This would be 7 pi over 4. And then 8 pi over 4 would just be 2 pi or 0. So you can see quickly how we can get the radian measure of angles. Now let's just write the degree equivalent of those. So 3 pi over 4, 3 times 45 would be 135 degrees. 5 times 45, this angle right here would be 225 degrees. And then 7 pi over 4, this would be 315 degrees. Okay, so that's going up by 45s. Let's go up by 30s. 30s and 60s are going to be similar. So I'm going to draw a line right through here. And I'm going to draw a line through here. I'm going to draw a line through here. I'm going to draw a line through here. Each one of those blue lines is in 30-degree increments. So this line would be 30 degrees. This would be 60 degrees. This would be 120 degrees. This would be 150 degrees. This would be 180, so then this is 210 degrees. This is 240 degrees. This would be 300 degrees. This would be 330 degrees. And now let's write their radian equivalent. So 30 degrees times pi over 180 would be pi over 6. So if this is, oops, watch how this works here. If 30 degrees is pi over 6, it's 1 pi over 6, right? So if that's 1 pi over 6, this is 2 pi over 6. This is 3 pi over 6. This is 4 pi over 6. This is 5 pi over 6. This is 6 pi over 6. This is 7 pi over 6. This is 8 pi over 6. This is 9 pi over 6. This is 10 pi over 6. Um, 10 pi over 6. This is 11 pi over 6. And then this is 12 pi over 6, or 2 pi again. So that's our basic construction of the unit circle, and you could see how it's a lot easier to number in radians. I'm not a huge fan of this. I'm not going to make you be a huge fan of this. I just wanted to show you how to construct it and how radians and degrees play nicely together. We'll talk more about this in the next section. What we're going to do to finish up this section, though, is talk about arc length. So what arc length means is when we have a circle, how far is it around the circle? Like how actually long is that piece when we have a central angle and we have a radius? Theta is the central angle. This vertex is supposed to be in the center of the circle. So the formula for arc length, it's a very basic formula. Arc length is equal to the radius of the circle times the angle in radians. So we'll do 3 different combinations of this. What if I told you that theta is equal to pi over 3, the diameter is equal to 6 inches, and I want you to find the measure of the arc. So let's set this up. The measure of the arc is equal to the radius times our angle in radians. Okay, well if the diameter is 6, that means our radius is 3 inches. Our angle is already in radians. Pi over 3 is a radian measure. So the measure of the arc is equal to just pi inches. Let's try another one. What if I told you the angle is 20 degrees, the radius is 5 inches, and I asked you to find the measure of the arc? Well, this one's a little bit different because when we were talking about the measure of an arc, that's equal to its radius, but we can't use 20 degrees. The angle has to be in radians. It's not a big deal. Let's quickly convert 20 degrees to radians by multiplying what we want over what we don't want. If you want, you could use your calculator to reduce this, but 20 over 18, the zeros cancel, 2 goes into 18 9 times. So the angle will just be pi over 9. So therefore, our measure of the arc is equal to 5 pi over 9 inches. We'll do one more. What if I told you the measure of the arc is equal to 2.5 inches, the radius is equal to 8 inches, and I asked you to find the central angle in degrees. So these are all just a variation. All right, so let's figure this out. The measure of the arc is equal to the radius times our angle in radians. So the measure of the arc is 2.5. I'll plug that in right here. The radius is 8 inches. So if we just divide both sides by 8 inches, we get that the angle in radians is equal to 2.5 divided by 8, which is 0.3125. That's the angle in radians. We want it in degrees though, right? So let's take this angle and convert it to degrees by multiplying by what we want over what we don't want. So our angle in degrees now will equal 0.3125 times 180 over pi. And that comes out to 17.9 degrees. All right, thanks for following along. Stay tuned for our next section.